Hi grade 9s and welcome to Natural Sciences with me, Aubrey. Diffusion and osmosis are important processes in nature. By diffusion, gases move into and out of our blood. Gases also move into and out of plants for the processes of photosynthesis and respiration. Molecules move into our noses and we are able to interpret the smell. Osmosis is a process that happens in plants when water enters the plants through the cells of the roots all up into the plant to where the water is needed. Osmosis is also the process in animals by which water moves around their bodies. Let's go to Asanda for our first question of the day.
And we're back here and we're ready to work and ready to have lots and lots of fun. I hope you are too. Hey guys, today we're at Westridge High School and in today's natural science lesson we're going to be looking at diffusion and osmosis. Interesting.
Very.
How are you doing?
I'm fine, thanks yourself.
I'm very good, thank you. So tell me about your hobbies.
Well, as I said before, I like music.
Okay.
I like to play the keyboard and like reading as well.
You like reading as well?
Yeah.
Nice. So, like, what can you play? What's your most dramatic song?
What do you mean? I'm not
when
sure.
you play on the keyboard?
Well, I'm not sure actually. I'm at school at the moment, so I don't really do
Oh, so you're still
performances.
studying it?
Yeah, I'm still studying
nice. Okay, so why don't you go ahead and ask your question?
I'd like to know what is meant by different states of matter.
Well, what is meant?
In this lesson, you're going to do a few experiments, gather and analyze data. You're also going to pay special attention to different variables and how to make the experiment fair. And this leads us to all three learning outcomes. Learning outcome number 1, scientific investigations. The learner will be able to act confidently on curiosity about natural phenomena and to investigate relationships and solve problems in scientific, technological, and environmental contexts. Learning outcome number 2, constructing science knowledge. The learner will know and be able to interpret and apply scientific, technological, and environmental knowledge. Learning outcome number 3, science, society, and the environment. The learner will be able to demonstrate an understanding of the interrelationships between science and technology, society, and the environment. States of matter are the three phases or physical forms in which matter exists, namely solid, liquid, and gas. Matter can move in between these states, usually when heated or cooled. Matter is made up of particles, molecules and atoms which are able to move. In solids, particles are close together and vibrate around fixed positions. In liquids, the particles can slide over each other and they are held together loosely. In gases, the particles are far apart and free to move around in all directions, colliding occasionally. The particles move about because they have kinetic energy. If I were to spray perfume on my wrist, the particles would move around in and about the air particles around me. We know that this happens because soon people close to me will be able to smell the perfume. In 1827, Robert Brown put a few grains of pollen on the surface of some water and observed it under a microscope. He noticed that the particles moved shakily on the surface of the water. Brownian motion is the movement of particles in the water or in the air caused by collisions with neighboring particles. If you put a cube of sugar in your tea, the sugar will dissolve and the particles will mix with the tea. Eventually your tea will taste sweet. Why? Because the sugar particles are evenly distributed throughout the cup, even though you don't stir it. Diffusion is the movement of particles from a region where there are many of the particles to where there are few. This means that the particles mix with other particles until they are more or less evenly spread out. The movement of particles is affected by temperature and by pressure. As temperature increases, the molecular motion and diffusion rate also increase. And if the substance that is diffusing is put under pressure, it diffuses faster. Activity 1. Now, this is an experiment in diffusion that you can do together as a class. Firstly, close the doors and the windows so that there isn't a draft. Secondly, the teacher will stand in front of the class and spray copious amounts of bathroom spray. Start the stopwatch. As soon as you and your friends can smell the perfume, stick your hands in the air. And when the people of the back of the class can smell the perfume, stop the clock. The learner will now pause the DVD and attempt the activity. How long did it take for the molecules to diffuse to the back of the class? On a hot day, you'd expect the molecules to diffuse a lot faster than on a cold day. Perhaps you could try again this experiment in winter. Now let's catch up to Asanda for our second question of this lesson.
Hey Lebu.
Hi,
How are you?
I'm okay, and you?
I'm very good, thank you. So Lebu, tell me about yourself.
Well, I love singing and chilling with friends.
Singing? Oh, nice. What do you sing in a group or just for fun? How does it
Just
work?
for fun.
Just for fun?
Yeah.
You're going to sing for me?
No.
Oh, come on, Lebu.
No.
Just a little bit, just a little bit. You don't have to do it now, but a little bit later. Okay, awesome. Go ahead and ask your question.
I thought concentration meant to pay attention. What does it mean in science?
Guys?
Concentration applies to how much of a substance is mixed with another substance. This term can be used for any type of mixture, but most commonly for a solvent. It pertains to how much of a solute is in a solvent.